All right, it's 15:30 or 3:30 for those of you from the US. This is IETF 118's EMU working group session. Please note this session is being recorded. I assume I don't have slide controls. So. All right, this is the note well, which covers all of our policies, or a large number of them anyhow, that apply to our meetings. So if you're participating in this meeting, you agree to follow those policies and procedures. And in particular, we have things like patents. In fact, we do have patents filed against, or patent disclosures filed against some of our documents. So it's kind of important that you do pay attention to those and let us know if you have patents. Anyhow, all of that information is encoded in the BCPs that are linked on this slide. You're welcome to look them up and read them. I'm sure you've seen them many times. Next, please. And the note really well. I will read this to you. IETF meetings, virtual meetings, and mailing lists are intended for professional collaboration networking. So be really nice. We have a code of conduct, RFC 7154. We have an anti-harassment policy and procedures, RFC 776. Please talk to the Ombuds team if you feel like you are concerned about how these things are going. But basically, this slide says, be nice to one another and let's be professional. Next, please. All right, as Joe has mentioned repeatedly, please sign into MeetEcho. We have the on-site tool, the light client. Keep your audio and video off if you're here. And for the remote participants, make sure you don't turn on your audio or video unless you are actually recognized or chairing, which obviously you're not. Okay, agenda. We have a note taker, 2 of them actually. Thank you. I won't go over the chat. That's part of built in. The video comes through MeetEcho. Use the on-site tool. Okay, so very briefly, we have a couple of working group documents. They are both, they've both been submitted to the IESG. I don't think Paul walked in. No. Okay, so Paul hasn't walked in. So TEEP version 1 is in the AD evaluation phase. I actually checked with Paul several weeks ago and he was about to do the write-up, but I have not seen anything. So I dropped him a note asking to see where that is. EAP, aka forward secrecy, is apparently in the hands of the authors. Jari, you or someone else want to speak to that?
Jari, yes. For better or worse, it's in the hands of the authors. So we have, by my count, and Paul isn't here, so I can't confirm, but I think there's 2 things. There's one nit from the IANA reviewers that had to be folded in, which has been done but not submitted. And then we promised to confirm on the list something that we discussed in the previous meeting, which we haven't done. So okay. My fault, but we will get to this.
Okay. All right. So we don't have slides for. No slides for that. Okay, so EAP ad hoc was discussed at IETF 116 in Yokohama. At that time, we asked if there was any apparent support for the document in terms of maybe the working group adopting it. There hadn't been a lot of show of support at that point. It was supposed to be taken to the mailing list, and I guess between the authors and the chairs, we probably thought the other was going to take it to the mailing list, and so it hasn't gone anywhere. Goran, do you want to say a few words about it?
Yeah. Can I stand here? Okay, Göran Selander. I didn't prepare any slides here because this has been discussed in the working group for some time, and there are no major changes to the document. So just a reminder for those of you who don't know what this is an EAP method for ad hoc, which is a lightweight authenticated key exchange produced by the Lake Working Group and approved in August. So it's now in RFC editor's queue, which makes it a good time to start building other applications of it. And so what ad hoc is doing is basically making use of CBOR and COSI. An ad hoc message is a CBOR sequence, and that using CBOR and other optimizations, we make this very compact. So and there are various advantages of that. If you're interested, you could come and talk to me. So, but you could think of EAP ad hoc basically as a mimicking of EAP TLS, RFC 19190, with some minor adaptations for the use with ad hoc. We think the draft, we are not really done with the draft. It's still work in progress, but it should be straightforward to see that it's possible to complete the exercise by mapping from EAP TLS. So yeah, what else did I write here? Yeah, so we have asked around for support, and unfortunately, some of the supporters are in the CBOR working group at the moment. But I have some proxying which I can do if we get to that. And there are also people who are not participating in IETF 118 who are interested in this work. In particular, one company working with OEMs in the car industry who want to use EAP ad hoc. Some people want to use it to key MACsec. And there is interest in 3GPP. So there is a new work item on ambient IoT, which is targeting constrained devices. And as you know, EAP is one of the modes of authentication in 5G. I think I stop there. Any questions, comments?
Okay, so we're looking to hear statements, either to the mailing list or briefly here that people are interested in adopting this or think that this is something worthwhile doing. As I said in Yokohama, I think we had 4 out of all of the participants, and nothing obviously happened on the mailing list, so it's not clear at this point that other than the authors' statements of interest that we have backing for this. Wasn't sure if you were gonna. Okay. Does anybody want to offer any statements at this point, or show of support? Otherwise, we can of course take it to the mailing list as well, and go through the formal process. But is the queue mechanism working? I can't see. Let's see, Renzo. Okay.
Yes, Renzo Navas. Yeah, I'm a new face for this working group, but I've been involved in Laking and COSIO's core IoT related. And at the time, I'm from academia. We were using EAP for many things, and I support EDOC for EAP. Because for IoT, it's EAP. It's a lot of flexibility, and we're missing a lightweight approach, and EDOC fits nicely. But I speak on behalf of academia.
That's fine. Margaret?
So I would wonder, especially now that people can do it remotely, if we could get the people who want this to talk to us and tell us why it's better for them than all the other standard EAT methods, which I don't understand. So if it is, I think we should do it. And if we ought to really be referring them to one of the other methods, I think we should do that. I don't think we should just kind of say, well, you want an EAT method, but we're not going to talk to you.
No, and we're not making a decision right here. This was mostly to drum up support, or to, if it went the same way as it went in Yokohama, then we would be, it would be pretty clear that there is really no reason to continue this.
So, sorry, I'm trying to log in, but anyway,
Yeah,
Alexander Pavlov. So I've worked in the past a lot on EAP over, for example, over LoRaWAN, when it was really in the beginning and things were like the LoRa Alliance were in its infancy. And I really regret that in the end it was not the EAP standard-based solution that was chosen, but something other different. So I think that here we have a real important job to make, to have this EAP lightweight mechanism for IoT. Because I mean, LoRaWAN is one case, but there are like a bunch of other IoT technologies, low power technologies that are going like popping up every day, and every time they reinvent the whole thing, and just like EAP is something that is. I mean, it's ubiquitous around the industry. So I think that's important work, and I would support and I would work on that as well.
Okay, thank you. All right, so I think it obviously feels like, well, go ahead. Please go ahead, Goran.
Okay, thanks. We're looking for the button. So just to address, why don't we use another profile for IoT? And I mean, what we're doing with ad hoc, what the Lake Working Group has been working on for a number of years, is to minimize the message overhead. So we're looking at messages which are less than 45 bytes. And that has a big impact on the performance of IoT devices, because there's power consumption associated to transmission. So longer lifetimes for the devices. That's why you want a very narrow, very slim profile of the A key.
All right, so I think we can take this to the mailing list as a formal working group call for adoption, and we'll get that taken care of shortly after the meeting. So next up is something that it says on the agenda. It's termed as yeah, but well, all right. So the slides say MKA over IP, and I'm sure Human is going to tell us all about it.
Yes, thank you. So my name is Human Bitgoli. I'm from Nokia. Basically, the next slide, actually, please. Thank you. So as you guys might know, there's this new thing, which is the quantum computer. And apparently, it's going to break a bunch of PKI algorithms. So anything using IPsec, SSH, TLS right now, when it is using PKI, Diffie-Hellman, et cetera, is going to be broken. Now, there is, next slide, please. Now, there is by chance, a standard in IEEE, we call it MACsec, you guys all know about it, that is quantum safe. Again, by chance, 10 years ago, 15 years ago, whenever it started, they use AES 128-256 to wrap the SAC, the data path key, and they distribute it. So us in Nokia, we start thinking that, with this quantum computers coming online, and the fact that some of these algorithms from PKI point of view are broken, how we can start introducing a quantum safe network that is really a line rate encryption with very low latency. And since we already knew that, when it comes to MACsec, it is quantum safe, we kind of thought that why not use that technology, not to reinvent the wheel, very simply try to kind of modify the technology as it has been done previously, and try to bring this quantum safe type of encryption into the market. And actually what I'm going to explain is one part of this technology, which we are trying to put MKA over IP. In the next couple of slides, you will see why we are trying to do that. So here are the different type of packets that there is. The first two rows, those are already existing MACsec packets in the world. The first one is actually in the IEEE that runs authentication over the entire packet and then encrypts the payload, including the VLANs. The second one, I guess 10 years ago, somebody wanted to do VLAN switch, wanted to encrypt the packets over a VLAN switch network. And then they say, well, why not put the VLANs into clear so you can manipulate the VLANs, pop the VLANs, swap the VLANs, whatever you need to do. And that has been in the world for the past 10, 15 years. And as long as I know, it's not in the IEEE standard. So we introduced MACsec engine in our NP. Call it a bug, call it feature, whatever you want to call it. What we did is that we start making the authentication and encryption offset to be programmable by our software. So basically, we can go into our NP encryption engine and we can say where the authentication or encryption offset starts. And doing so, we can start putting MPLS labels into clear. using the same MACsec engine as it was previously. We can put IPv4 headers into clear. We can put IPv6 headers in clear. When it comes to SRv6, we can put SRH into clear. So when we shoot these packets through a network, MPLS network, IP network, IPv6 network, anybody can manipulate the header. When it comes to the labels, swap the label, pop the label. When it comes to the IPv6 or IPv4, subtract the TTL, manipulate the SRH, etc., etc. And all this works with the MACsec engine, which has the 802.1 AE header on it, line rate, low rate latency. And what we see is that a lot of federal customers, they love this because it's quantum safe, first of all. As we said, MACsec is quantum safe. And then next is it provides encryption end-to-end between two routers in an IP network or MPLS network. So when we started, here's a data path. Then the next slide, please. So again, this I already explained. Basically, when you start using, we call it AnySec because it can encrypt any layer of OSI. But basically what it comes down is that when you have two PEs that does this type of encryption, you can have any transit routers into the network, LSR, SRv6 routers into the network, and they manipulate the header and you have an end-to-end encryption. As I said, most customers, they love this because it provides them a little bit extra with MACsec. On MACsec, as you folks know, when it comes to the router, you need to decrypt on the ingress, make a routing decision and encrypt on the egress and shoot the packet out. So there is a very small moment in there that the packet is actually in clear. And when it comes to federal government, they don't like that. They are thinking that if the router is not physically secured, you can put a probe on it and start looking at all these packets. You can mirror the packet out or et cetera, et cetera. So that's why they really love it. But next slide, please. So here's again another example of the packet. As an example, we have 3 routers here. It's using MPLS segment routing. We can actually identify LSP. So there is like a CAM in the NP. We can actually say that here's the MPLS header or here's the IP header. We identify that IP and we have entire key infrastructure behind it, key management behind it, that we can actually assign the right pre-shared key to this stream of the IP or MPLS and encrypt it with its own stack and with its own pre-shared key. But as you can see, again, labels are in clear and you can actually manipulate it. So all this stuff, again, using MACsec, the only thing that we changed here is the fact that the authentication and encryption is now programmable, and we actually have a way to lock into an MPLS header, to lock into an IP header, SRH header. In addition to the layer 2 header or the VLAN header, we can lock into all these other different OSI layers and encrypt a specific flow end-to-end throughout the network. Now, the problem becomes we are using MACsec engine. We are trying to communicate that sec tag from one router to the other router. As you folks know better than I do, MKA uses IP. IP is layer 2. It is actually ether type that kind of presented. So in our head is not trying to reinvent the wheel. How can we make MKA to be communicating these stacks between two router over an IP MPLS network? Next slide, please. So basically all we did is that we presented the MKA as is, and we added a UDP header. The reason that we added UDP header and not TCP is because we did not want the retransmission. MKA, again, as you folks know, already has a heartbeat, 2 seconds, 3 packets, you miss it, MKA goes down, brings down the encryption, we start black holing. So we can program a UDP throughout the entire network that actually identifies the MKA, and then we put the IP header on top of it. You might ask, what is the IP header? It's very simple. When it comes to the MPLS segment routing, you create a tunnel between 2 loopback IP addresses. That's how we identify the LSP or the SRv6 tunnel that we want to encrypt. And we use those 2 IP addresses between the loopbacks as the source and destination IP address. And the UDP identifies the MKA itself. So we shoot the packet from the encrypting router to the decrypting router, MKA. The decrypting router looks at the UDP header, extracts it, sends it to the same code that MACsec has it, and everything just comes up. And now you have IP MPLS encryption throughout your network using MACsec as standard and using .1x as standard without changing any code whatsoever. This is implemented in our routers, and it's working. We have customers on it to encrypt like management traffic, to encrypt data path traffic, quantum safe type of stuff. And basically, the reason I'm here is we've been getting asked that, hey, can you make this MK over IP UDP to be a standard that, we can take it to the next step? And that's the reason I'm here, trying to get inputs from you folks, whether this is a home for it or you don't think that's a home for it, what we can do. As you can see, it is a useful technology, and really it takes a couple of days of coding to make this whole thing work.
Yeah. So, well, this working group has EAP in the name, and you're using EPOL packets. So EPOL is something that's developed in the IEEE, and it carries EAP, but it also carries other things, right? So it was designed to carry EAP, but then people put in MKA and all these other various things. So this working group probably wouldn't deal with MKA because we're dealing with the EAP authentication. But I don't know what other working group would in the IETF right now. So it maybe this is something that should go to SEC dispatch or potentially this working group could be recharted to do something like that. But I don't know that that's what we would want. But that's a question. Yeah, sure.
So Paul Autos 80. So my initial thought is that indeed this might not be the best fit for this working group, where to send it and how to send it. We have to see, like SEC dispatch could be an option, but maybe the routing area dispatch could also be an option, because this seems a little bit routing-like as well. And since I'm on the microphone now anyway, I'll take off my hat and I'm speaking as an individual. You keep saying it's quantum safe, but of course that all depends on how you distribute that key that you use with MACsec. And I'm not sure if you have a quantum safe key distribution mechanism, because we are working on that in IETF, like using whatever IKE or TLS or other things. So I'm not sure if this is actually quantum safe, but I'm not I don't know MKA, so I don't really know the details of those protocols of how you distribute those keys.
Yeah, I mean, that's a good comment. With regard to the quantum safe, I mean, I think I don't have the PhD hat on, so I mean, I'm not going to say what is quantum safe or what is not. I'm not going to prove one way or the other. What I know is what I read from NIST and, from the other standards. And anybody says, hey, yes, 256 is quantum safe. Now, if it's not, by all means, I'm going to step back and I'm going to say it's not quantum safe, right?
Sorry, no, let me clarify. Using pre-shared keys is quantum safe. It is how you get those pre-shared keys to both endpoints so that they both have the key to use it.
QKD is on top of this. Let me be straight.
Okay.
So this whole thing, and I didn't touch that part of it, this whole thing is going to get hooked into the QKD, right? So I'm not going to have the the pre-shared keys downloaded via SSH or anything like that. QKD going to be the top layer of this that is going to download the quantum safes via, AES-256 to the, and I think that's a conversation that I actually wanted to have on the side. But
yeah, thanks, Dan Harkins. So why isn't PANA suitable for you to solve this problem? RFC 5191, it does EAP over UDP.
I don't know that. I haven't seen that RFC. So I know that there was a draft in there previously, long time ago, that was trying to put EAP over UDP as.
It's an RFC. I think it's 5191.
Okay.
So it may.
It's exactly the same thing. If it is
a problem for you, yeah.
Okay. All right. Thank you.
And please try to keep your comments brief as we're running over time.
Michael Richardson, I think I'm next now, right?
Yeah, you're next.
Okay. So if I understand your explanation is that you felt that you have MKA's quantum safe and you want to use it in other places, But as Paul says, it's just PSK. And so we already have TLS with PSK for EAP. And I think we even have IKV2 over EAP, don't we? Yeah, I think we do. Yeah, and we could do PSK with that. Yeah, I think we do. So there's already several protocols that are doing it. Plus, we're figuring out how to do the certificate-based stuff in a quantum safe way. So this just seems superfluous, except that you were talking about how your hardware can encrypt and decrypt things. So it almost, I'm sorry, it just sounds like you're saying, I have hardware that does this, I should apply it to all sorts of places. And I don't really understand what the use case is, whether this was for keying MACsec. No, it's a general EAP method, as I understood it.
So I think we are kind of stuck on the quantum safe. That's not why I'm here.
Okay.
Yeah.
Okay.
So all we are trying to do is take MACsec technology, which is line rate, low latency, into MPLS LAN and into IPv6 LAN. Let's leave it at that.
So you want to key MPLS and other type things using MKA, and you need to run it over UDP because the two endpoints are there.
You got it. Yes.
That sounds totally a reasonable thing to me.
Yes,
okay,
that's exactly.
That sounds like a totally reasonable thing for that. Whether it fits into this working group or not, I really don't know at this point. I think that you should just go ask an IANA for a port number.
Yeah,
and
that's
good.
it.
You don't even need a draft.
Okay, thank you.
And Hannah has a port.
So you're set. Sorry, I think my reason to be up here just went away. Although he is exactly correct, right? So just because you're using a PSK does not make you squeaky clean, and QKD may not help you. It just depends on what you think of QKD. I don't. It looks squirrely to me. I mean, you're now exposing headers that weren't exposed before. You got to protect headers, and it might not be protected. Like it's like you're slicing and dicing things that I think may be funny looking, right? But that's just my opinion. I'm sorry, I'm dead cool.
It is funny looking. It puts MPLS labels, but that's where the technology is going.
Underneath in normal MPL and normal MACsec, they would have been inside the envelope, right? And you're now exposing them outside. And the question is, are you still protecting them as well as you would have done if you did a MACsec?
Well, again, I think we are trying to dig into the technology. Let's leave the technology on the side. My question was how, I mean, if you want to argue with that, we can argue with the fact that the VLAN isn't clear too. Is that safe? I don't know. That's already in the world, right? I mean, that's not my implementation. That's
the more you expand, the more you expose a header, the less safe you are, right?
Sure.
I mean, I think that's pretty
so
standard, right?
Today with the VLAN in clear, we are saying that's not safe.
Okay, folks, I'm going to have to cut this short because we're eating into Alan's time, and Alan is here to present EAP.ARPA. Thank you, Hooman.
Okay, this is Alan. Next slide, I guess. There we are. This came out of a discussion in San Francisco on Friday when almost nobody was in the room. There's a couple of proposals for doing provisioning over EAP, where you want to get either some kind of network access or actually do the provisioning over EAP itself. And people were proposing multiple different things. And one of the outputs was, let's just pick a domain that is non-routable that we can then define as this is for provisioning. So the issues we have with things like EAP-TLS is it allows for server unauthenticated provisioning mode for anonymous network access, and the documents are completely silent on how this happens. The WBA has defined their own EAP method, which is EAP-TLS, effectively, but under their own method ID to do exactly this, rather than coming to the IETF and going, we need some way of doing this. So let's use a common domain. If we go to the next slide. We need a domain that's under IETF change control, that doesn't stomp on anyone else's domain, that's not routable via radius proxying, that if you send it to a server which doesn't support this specification, won't do anything exciting and will reject it rather than routing it. So this domain is fail safe in that we can use it and it won't affect anything. So we can define new behaviors for it. Next slide. So the proposal is to add eep.arpa to the ARP registry. The IEB needs to agree. We hope this should be okay. And then we define a new EAP ARPA identifier registry, which is name at eep.arpa. And then as technical details, if say a vendor wants to do something in that space or 3GPP, they can do 3GPP dash something at eep.arpa and define their own provisioning method. There's other specifications which define DPP at eep.arpa or portal at eep.arpa. And this document just concentrates on eep.arpa, defining the registries and saying this is generally how you use it. And then for anyone who wants to define a provisioning method, they can just define an identifier at eep.arpa. We don't have to go back to the IAB, and everyone knows what this means. Next slide. It's a proposal. There's very little feedback on the list. Any comments? Try to keep it short.
Paul.
Yes, no?
Paul, again, speaking as individual. So yes, you can get a special domain, and people at the ISG kind of dislike special use domains because there's a whole lot of history and problematic things with it. Recently, we got the .alt domain, which is guaranteed not routable in a DNS forever, and it's no registration, no nothing. You can just use eep.alt, and it's guaranteed to just forever work.
Yes and no.
You don't need it to resolve.
No, you don't need it to resolve, but you need it to not conflict with anyone else. And if I can use alt for my thing and you can use alt for your thing, then neither of us can agree on what to do. Elliot.
Hi, so Elliot here. There are a couple of differences between this and alt. Alan mentioned one. The other difference is that this is relating to not so much alternate name resolution or approaches, but rather it's a signal. It's a signal to a mechanism that is for IETF purposes. So it's not something that just anybody should be able to access, but there should be a policy to it. It should point to a specification. The specification should be, say, when you see this, here's what you do. Yeah. And so if you're using, the EAP-TEEP specification or something else, it says, okay, here's RFC such and such, go and use it. So I actually think this is a good idea. I think it's a good idea in general. In fact, I'm not going to comment much further other than to say, work the details with the IAV.
Yeah, that's exactly it. So if we have a standard way to do standardized provisioning, we need some kind of name under IETF change control.
And very specifically, right? This is for the NAI, right?
Yes.
It's not just for any use. It's specifically for an NAI. It's, to identify that sort of processing next step.
Yes. So this document defines eep.arpa as special for EAP provisioning. And then the identifier within username at eep.arpa is whatever that specification does. And so now the server knows when it gets DPP at eep.arpa, it's going to do this exact thing. Or if it gets something else at eep.arpa, it's going to do something else. And then you can interoperate and you know what's going on. And there's a specification behind it. Everyone's in favor.
So would there be a draft for this and a registration?
Yes.
For this? Okay.
So this document defines the eep.arpa domain and it defines the EAP identifier registry. Okay. So you would have a registry for DPP, you would have a registry for, say, captive portal, where you get some kind of captive portal access. And the idea would be every specification would say, here's the identifier at eep.arpa. That identifier goes into the registry, and the specification describes what you do when you see that identifier. We already have EAP noob. That arguably should have been noob at eep.arpa, but that's water under the bridge at this point. So there is precedent. People seem to like it. There's lots of uses for it. I have nothing else then. Okay, good. Next,
All right. Michael, you're on for note taking because Jan-Fred is going to discuss EAP FIDO. Yes.
So, so good afternoon, Stefan Winter here. Together with Jan-Fred, we're talking today about an EAP method which leverages FIDO security keys, which you sometimes also find called passkeys, because that's much more fashionable today. And the fact that we are talking here is actually a surprise if you remember IETF115, next slide, because in the last EMU session at 115, Joe asked me about, wouldn't it be nice to have passkeys and EAP somehow work together? And basically I was saying, oh, this will never work. So still we're here. I made one mistake back in the day, and it was a very interesting one, because I thought it's not practical, and you always have to authorize a FIDO transaction with a fingerprint or PIN or whatever. And that's not good if you use EAP on Wi-Fi and your device in your pocket should be authenticating without you touching something. I made that mistake for a simple reason. When you use passkeys or FIDO keys on the web, there's two standards working together. There's a stack. The top stack is WebAuthn. That one requires user presence to be checked. But the underlying CTAP version 2, which is the hardware end of things, has these things as options, and you can turn off the option, and then you get a silent authentication. Next slide, please. So this is really very explicitly in the standard. You can turn off presence and user identity verification, and then you authenticate silently. So the idea for us was, if that works, we can have a method that can authenticate this user silently when he logs onto the network. But at our option, we can also say for this particular transaction, maybe once a week, or maybe if you use it in a different EAP context, like for VPN access, you can still require a user interactive transaction. Next slide, please. So what you're seeing here today is basically that we will be using the entire CTAP version 2 backing for FIDO keys as it was designed to the standard. And instead of the WebAuthn, we have this own specification of EAP FIDO, which puts the passkeys and FIDO keys into an EAP context and lets you authenticate there. Just to be clear for the beginning, we are not talking about key registration. The registration process is a whole different beast than just authenticating with an existing key, which you already have. So that's what we're concentrating on, just authentication. And the goal of all this is to have authentication of the client with a public-private key pair, just like with client certificates, but without all the hassle that certificates bring, like that they expire and that you have to use an obscure client-server protocol to rubber stamp them from CA and all that, let me call it, stuff. So with that, I'm done, and all the details were worked out by Jan-Fred, so this is fine.
Okay, thank you. Okay, I wrote background problems with EAP, but I mean EAP TLS-based methods. So I think for everyone in this room, it shouldn't be a surprise that secure TLS configuration in EAP TLS-based EAP methods is really not trivial. Looking at you, do not validate. If you select it, it just works, and that's bad. Passwords are bad. We want to move away from passwords. TLS clients, as Stefan just said, you need to bootstrap them. Running a client certificate infrastructure is not really that easy. Next slide. So what we want to do with EAP FIDO is have a TLS-based, EAP TLS-based protocol, but Jan-Fred, that is broken. No, we try to avoid that by having one configuration item, the one string to rule them all, that we can expect the user to actually know. If the user knows I'm a member of DFN, then maybe I need to put dfn.de into my configuration, and then starting from that, everything works. Next slide. So the basic protocol is we have the FIDO token, whether it's an external USB token or built into the device. We have the device and the server. Device and server do a TLS handshake. The server requests a FIDO authentication. If we want to use passkeys or discoverable credentials, then we can skip the middle part and immediately return a signature and authenticate the user. If we want to have authentication with usernames, then the client needs to send the username to the server, and the server needs to respond with a list of the user's public key identifiers for the FIDO token. And then in the end, we can have a protected success or failure indication immediately baked in. Next slide. Yeah, so the features we tried to have for EAP FIDO is the possibility to have a username-less authentication, better privacy with this discoverable credentials. It works very good. We have dynamic authentication requirements, as Stefan briefly said. We can have a policy attached to, for example, each individual FIDO key if we want to have silent authentication or not, by just restarting the FIDO authentication flow again if the requirements were not met the first time. And minimal configuration. We have one thing that the user enters into their device, and hopefully they can't get that wrong, or if they get it wrong, then it won't work, because the relying party ID for the FIDO authenticator then is just a mismatch. Next slide. Yeah, we assume that the EAP server has access to a database with all the public key identifiers and the respective public keys for the FIDO authenticator. So we don't do provisioning in band, we do it out of band. If there is actually a need to do that in band, then we can see if we can push it in, but for now we want to leave it out of scope. The primary use case is environments like eduroam, where you have a lot of bring your own device, and you can, or my opinion is, you can expect the user to go onto a web portal, do a registration via WebAuthn, and then have the EAP server access that database. We have not yet specified deprovisioning of the credentials. That requirement comes from the discussion, I think it was also in London, about EAP die. Yes, I know you have credentials. No, you don't have access anymore. Just go away. Don't try again. Or, yeah, well, we have a server problem. Please try again in 30 minutes and not in 5 seconds, because we have really a non-negligible amount of load on especially eduroam federation proxies just to send rejects for people that don't study at the university anymore, and left the eduroam configuration on their devices. And with that, we also want to have a bit more verbose error handling. If we define a new EAP method, then we can do it right from the first second. Okay, next slide. We had a site meeting yesterday in the evening where we went over some of the open questions for the specification. One big question is, which one string to rule them all do we want? We can have either the network access identifier, so the routing realm. We could configure the expected server name or the FIDO relying party ID. All three somehow valid options. We had a very weird idea where I don't know if the DNS people will bite our heads off if we just define a static prefix that all FIDO, EAP FIDO servers need to have a certificate for arbitrary prefix string dot your realm. Maybe we can have a serve label in the DNS that the client needs to look up the moment it gets provisioned. Would require network access at that time, is it reasonable to assume that devices have 2 internet connections? Well, that's open questions that we are open for feedback. Some of them were discussed on the lists. Some of them were discussed in the site meeting, where I will put the protocol somewhere and send it over the email list after IETF. Okay, so I think next slide, and that's the last somehow content slide, is what do you think about that? We think it's cool. We want to hear if you think this is rubbish or if it's cool.
No, it looks pretty cool. This is Elliot.
Yes.
The only thing is that FIDO is a large organization. Please be more specific in the EAP method name. As I already mentioned on list, like I tripped over the fact, I'm working day to day with people who are doing FDO. Just pick a name that, and in your documentation, make clear which FIDO mechanism you're talking about. Obviously, it's the authentication, the personal authentication stream, right? You guys have names for those standards. Just be clear. That's all.
Yeah, thank you. Yeah, I mean, I'm not that familiar with the FIDO environment yet, so and any suggestions on that name are appreciated.
I'm not FIDO
Yeah.
guy, so I'll leave that to the people who are more FIDO-ish.
Yeah, thank you.
Yeah, this is Alan. I think this is a good idea. One historical issue that people have had with EAP is how to configure it because it's too complicated. You use various TLS-based EAP methods. Which CA do you use? It's hard. How do you configure it? It's hard. Which ID do you use? Do you use an NAI or not? All that's historical. We can't change the existing EAP methods. We don't want a password-based EAP method. Passkey looks like pretty much what we would like to do. And at that point, you start narrowing down the other bits of the protocol and just do this, and it will be easier for everyone. I think a key thing here is this is something that the end user should be able to configure without really being able to get it wrong. Use EAP-FIDO for example.com. That's it, because everything else is too complicated.
I'm generally in support and think it looks good. One thing I noticed only today because of the presentations was that one of the previous presentations talked about wanting to make some modifications to EAP TLS to do the authentication. And I'm wondering whether we should think about whether that's a useful thing to do for more than one thing other than FIDO. And if so, perhaps to define how we do that and then use it for FIDO might make sense. I don't know.
Could be one of the reasons why we chose to define a completely new EAP method with EAP TLS baked in is that we feared that if we define that as an inner EAP method, that people would reuse the crappy user interfaces that don't have the right options to securely configure the connection. But if we can kill 2 birds with 1 stone, please.
Okay. Hai Guang.
Yes, my name is Hai Guang from Huawei International. I have 2 simple questions. Firstly is you use a FIDO, what kind of the credential you use, a fingerprint or you use face or something like that?
That's completely dependent on which FIDO, what the FIDO authenticator wants to do. Okay. So if the FIDO authenticator, the one that I used for my proof of concept implementation, for example, doesn't have anything, just a button that I need to press, and for silent authentication, I don't even need to do that.
Okay. Do you need to save any data on the server side? Use EAP FIDO.
On the server side, we need the registration for the FIDO key. So we need the public key identifier and the corresponding public key. So we need to have access to the registration database for like WebAuthn. We can actually use the same database because if a FIDO key was registered via WebAuthn, we can use it for authentication in EAP FIDO.
Okay, thank you very much.
Michael?
Michael, so Elliot, just a question about what you suggested. I think that what you said is, please don't call it EAP FIDO, call it EAP something else, banana, and it would then say in the document that you're using the FIDO blah, blah, blah. That was I heard you say.
FIDO has different authentication techniques.
Yes, so that's why I understood you didn't want it to just say FIDO, because that would just be confusing for everybody. But I wasn't sure if you just wanted them to be more specific in the document, or if you actually wanted them to say, as I say, EAP banana or something else.
Or EAP FIDO minus something.
Yeah. Okay.
So it's clear that it's not like FIDO, like EAP minus internet, but it's
okay.
EAP.
So EAP FIDO, other
Something.
letters after that would make you happy, but it could still say FIDO.
We want EAP IETF.
Well, no, that would be also dumb.
But
Joe?
Yeah, so I don't know too much about FIDO, but would the intent here be that somebody can use the same FIDO hardware to authenticate to their website as well as to the wireless network, or would they have to have two credentials? Like, are the profiles you're using, is that something you can do on the same device and have that be a multi-use?
Yeah,
thing?
you can have that multi-use, which if we don't take that to account, may open up some things to cross-protocol issues, but we are working on that to avoid that. But basically, the idea is if you have a FIDO credential registered for your institution, so if I have a discoverable credential for dfn.de, then I can use that to log into Shibboleth, single sign-on on the web, and also for network access via EAP. So basically, one key to rule them all. Yeah. So maybe the last question is this something that EMU should work on, wants to work on, can work on?
Yeah, so I guess the question is, other than minor changes to the document, choosing a proper name, was there additional work you wanted to do before?
I'm happy to push that thing forward as fast as possible because I want to write my master's thesis about this, and if I don't think that it will be ready at the end of my master's thesis. I only have 6 months to write it, but I expect that there will be a lot of velocity on the development on that.
Elliot?
Okay, so when we do these sorts of cross organizational things, what's really important, what's most important, is that the experts who work on FIDO authenticators are actually involved in the development and testing. So if you're obviously running on a master's thesis, timeline, this, as you just said, it's going to run further. So before we adopt this work, we should probably at least let FIDO know that, hey, we're working on it. Are there people over there who want to just join in? It's free. You can join the party without, any cost except to your time. And just to make sure that the work will be completed, not only completed, but and used.
Okay. Is there somebody specific at the FIDO organization that we should be reaching out to? I'm not familiar with the
and again,
structure
me
either. Yeah.
So you might have a brief conversation with the liaison side of the IAB, but My suggestion is that you can shortcut that through Jan Fred, and who probably does work in FIDO a little bit, or
Not yet, but
okay. So
right,
but it's important to find those people. I don't know who they are, but otherwise, what ends up happening is that organization gets surprised that we did an implementation that maybe they don't agree with in some way, and that would be very, very, very bad.
We actually received some feedback, at least from the people that are in the W3C WebAuthn working group. And they had already some comments that wasn't on the EMU list. It was sent to us authors directly, but we definitely intend to establish a communication there.
But they should be on the EMU mailing list. They should be the ones who are standing up and saying, yeah, we want this, because otherwise, yeah, we want this. Yeah, and yes, we will review it. Right. Those are one of when we do adoption calls, and I don't mean to speak for the chairs here, but this is common. We expect the key experts to review it, the document. They're going to be some of the key experts in this space.
Okay, thanks, Elliot. Deb.
Just a quick question. Do you care about revocation? Because classically, it's difficult with FIDO.
Well,
I mean, as long as you handle it, or if you don't care, then it's fine. Right?
Well, I think the idea is that the revocation here is the same as revocation with passwords. You just delete the account.
Right. So everywhere you have it, you have to go do that. Right. So if you're going to use the key in more than one place, you've got to do that work in more than one place. That's the advantage of certificates, right? You revoke them, and if somebody checks, you're good, right? It's just a question. It's just a question about whether you care or not. I don't care what the answer is. I just think you should think about it.
We will definitely think about it. Stefan?
Maybe I could just quickly say that these FIDO keys are always scoped to a specific domain. So you don't delete the entirety of the security key everywhere you use it. The deletion is always on this one domain where you had a key. If in Jafet's example he has this account at dfn.de, you would only delete it on the dfn.de server side, and then this relation with this key to this domain is gone, and all the rest of the key can continue to exist.
This little key that he uses on dfn.de only works in that one spot.
There's multiple slots on the key, but this slot will then be deleted.
I got like he was using it for more than one purpose.
I can use the same hardware token for different purposes, and now there's the difference between discoverable credentials and non-discoverable credentials. For discoverable credentials, if I delete the credential on my key, then it can't be used anywhere. But if I use non-discoverable credentials, then I use the server as temporary external storage to store something encrypted, and the server sends it to me. And if it matches, then so there we have a problem of revocation, but it's definitely something that we need to put in security considerations. We will think about that.
All right. Anyone else?
Yeah, if you have one more question, I'm sorry.
Yeah, go ahead, Elliot.
We should have badges with with
Yeah,
NFC, and then you can.
So I think that the other question is, I think there are different authentication standards. Even so, it goes back to the naming, but also more deeply, right? I think there are a suite of standards that can be used for authentication. Some of them are for like the tokens. Some of them might be for the tokens that we use, like to log into GitHub and stuff like that. I don't know if these are the same standards for that. And do you know? Because it may be that there might be a suite of things that the FIDO people might need to get into or might want to get into.
To the I think the second or the fourth slide. So do you want to answer that?
The slide's actually quite good, yeah. So there is the CTAP client to authenticator protocol specification.
Okay.
And that single specification does the passkeys you use on GitHub and the hardware security keys you use via USB. This is all wrapped up in one. It's currently version 2.1.
There's your banana there.
And there's the name, yeah.
There's your banana there, Michael. Yeah, so
That is the only spec we need, yeah.
Is exactly what, or CCAP V2 to make it
Yeah.
clear.
Okay. All right.
Thank you.
Thank you, Jan-Fred. And so I'll take the action to figure out who at FIDO to talk to and to let them know that we're looking at this and try to get them on board as well. Okay, so we are at time. I want to thank everybody and obviously probably we'll have to get a 90-minute slot next time so we don't have to rush through any of these presentations, but thank you, everyone. Do you need to cancel the room, or is it just shut off automatically? It just shuts off. Okay. I keep closing my laptop without signing out, and then I come back and it's like, oh, it's gone.
Yes.
Okay.
What was said was recorded for posterity. I'll show up.
Coleman, Big Dalton. Yeah. I don't necessarily see him. I don't necessarily see him.